Okay, so this is last time looked at we looked at what big three means. Okay, big three. There is a version of this one. This is called big five. Big five is not as big as big three. We'll talk about it later. Big five is only valid for C++, 11 and afterwards. But the important thing here is big three. Big three is any class, okay, any class such as this. I mean, you cannot have any class simpler than this. Any class defined will have default meanings for copy constructor, assignment operator, okay, and destructor. Also, there is this default constructor too. But these three are important. Why? Because if you don't define them, if you don't implement these three, for some classes, you will be in trouble. These classes are usually classes that deal with pointers. Any class that contains a pointer, of course, is not supposed to implement these three, but most probably it is. And we talked about the difference between a shallow copy and a deep copy. Remember what we said about our PFRAD? PFRAD is supposed to dynamically allocate space for some doubles. I don't know how many doubles, it depends on during the construction time. If you do a shallow copy between two PFRAD objects, this is what happens, shallow copy. And shallow copy is a very bad thing. You wouldn't know it, there is no compile time error. Most of the time you will not get any crashes, but bad things will happen. What kind of bad things? It's going to be when you modify one of the objects, the other objects data will be modified and etc. There are many other things, and we are going to see what they are. Okay, so be in control and override, or not override is not a good term. Implement this copy constructor, assignment operator, and destructor if needed. Okay, and in fact, if you are writing a class, let me show you a class. If you write a class where you think that big three is not necessary, okay, where you think that big three is not necessary, in that case, you will write, let me try to open these, and yeah, maybe this too. Okay. Let me, okay, time.h. Okay. So this one is a very simple class. It includes just hour and minute in it. It's two integers. Member-wise copy is okay. Okay. I'm not going to dynamically allocate anything. When the object dies, I don't have to do anything. So in this case, right after the constructor, you will say, okay, default big three is okay. That's what you would say in a comment statement. So anybody who is reading this would think that, okay, on purpose you didn't implement big three, copy constructor, assignment operator, and destructor. So this is what you should do. If big three is needed, then you implement it. Okay, this is how important it is. Okay, good. Don't forget about the attendance. Don't sign the attendance form, online form, unless you are in the class, okay? As soon as you are done, I am going to do this check. If you are not in the classroom, it doesn't matter if you are in the bus, if there is some emergency came in. If you are in the classroom, you sign your name. Otherwise, if you are outside, you don't sign your name. That's as simple as that. Okay, let's write a simple, my simple, let me save it as a CPP file. Okay. Where am I gonna save it? Okay, maybe maybe I should open that CPP and Okay, let me open that one, yeah. I don't know what I have in it. Yeah, that's good. Is this possible? Would this compile? Would that compile? The question is very simple.
Yes.
Of course, yes, it's just a simple recursive function. That's it. It doesn't do anything useful, but it would compile, yeah. Okay, I'm not going to do that. I am going to do this. Okay, I am going to write a simple class, my favorite class, and okay, that's it. So when I say AA, this will work. AB, this will work. And ACA, this will work too. Okay, what else? I can make this assignment A, guess the value of B. This one will work. What else? What did we say? Copy constructor, assignment operator, and the address of operator, right? I have a pointer of AP, guess the value of address of A, and this one will work too. Okay. Okay, so this should compile. Let's compile it. Okay, it compiled. Of course, when I run it, it will not do anything, right? Because I don't have any cout statements and etc. This will compile and this will, of course, run. It runs and yeah, so it says that my process has exited. So let's try to make this a little bit interesting and let's see what kind of things I can. Okay, let's try to see what kind of behavior I'm going to get. This makes a very nice, actually, exam question. What would I get out of these, etc.? If I can find my curly braces. Okay, this will be cout. I am going to write constructor, okay, and backslash, yeah, I found backslash. I found this too, and okay. So I implemented the no parameter constructor. So how many const, okay, no param constructor. So how many printouts I am going to get on my screen? How many objects am I constructing? How many objects am I constructing? Three. So how many printouts I am going to get on my screen? How many? Two or three? I have three objects, but I am going to get two. Oh, I didn't compile it. Compile and run. What happened? Yeah, I ran it. So no param constructor once and second. I am getting only two because for the third constructor I have my copy constructor. Okay. For the third constructor I have my copy constructor. There is a default copy constructor. That default copy constructor is built and it is run for this line 16 and I don't have a print statement in it. Let's write our copy constructor then. Let's write our copy constructor. Copy constructor by definition is say that I am going to take an object of A, okay, and this one. So this is copy constructor. I'm not going to do anything about this object. Okay, let's compile and run. What did they say? Invalid constructor, you probably meant constructor A address, okay? Reference, okay? So it says that you should do this, constructor A and reference, okay? Why? Because, I mean, if I have a copy constructor, I am not going to modify this object, right? That's one thing. The other thing is that you should take it by reference. If you don't take it by reference, there will be a copying happening, right? This is important. If I don't do this, if I don't take the reference, how am I going to call this function? I mean, this copy constructor. Call by value, okay? Call by value. And call by value takes the copy by copy constructor, but I am already calling the copy constructor. So copy constructor will call the copy constructor again, and it will call the copy constructor. Then it's going to be an infinite loop, infinite recursion. So that's a bad thing, okay? If I remove this one, it will either give me a compiler error or, yeah, again, it's the compiler error. If it didn't, the older compilers didn't give any compiler errors, okay? Older compilers didn't give any compiler errors, but it was a infinite recursion case. Now it's going to compile, okay, and 1, 2, 3. The third one is a copy constructor. Okay, for the assignment operator, it works. There is a default version of it, but since I did not implement it, I am not getting any printouts on my screen. Yes?
Can you explain one more time?
If I don't have this ampersand operator, ampersand sign there, so that means that it is not no reference, right? Somebody has to take copy of this. Somebody has to take copy of this object when I am sending this to it, right? Who's going to take the copy? Copy constructor. But I am already implementing the copy constructor. So while I am calling the copy constructor will call the copy constructor again. Okay? So that will make things a little bit messy. So let me show you this. Let's say I have a function which will take an object of type A, and it will not do anything. Okay? So this is my function A, okay? And after the assignment, I am going to do this function f and b. I am calling this function f on object. I am going to do this that way. Or let's make it static. Let's make it global. I know I shouldn't make global things, but and make it after the main. And this should return a void. Doesn't do anything. It doesn't return anything. It's just a function. So I am sending my b to, okay. Tell me what am I going to see, what I am going to see on the screen. One constructor, okay, no parameter constructor, copy constructor. From the assignment, I will not get anything. How about this function b? What am I going to get? Yeah, exactly. I'm going to get a second copy constructor. Output. Why? Because while I am calling that function f, I need to make a copy of this object b. Okay? This object b. And that object b has to be copied. Who is going to make that copy? The copy constructor. So when you make this call, this one will, okay, this one will make the copying, the copy constructor. That's why it is being called. How about this one? This function is returning a object of type A by value, and inside my class I am making this object and I am returning this one. I am not returning any references, I am returning an object itself. So I am returning a local object. Somebody has to make a copy of it, and I am going to return it, right? I am going to return it. So what am I going to do now? What do you expect? How many copy constructors I am going to get now? Let me get rid of this one. I have, okay. So two constructors, one copy constructor there. Another constructor, copy constructor would be, okay, a constructor inside it, right? There will be a constructor here, no parameter constructor, and return b will be this. Okay, And let's see how many copy constructors we are getting. Depends on the compiler. Sometimes compilers are very smart. They say that, well, you are going to ignore this anyway. Okay, maybe I should do this. B or A gets the value of B. So I'm going to make this assignment. And let's execute this. Compile and run. Okay, so no param constructor, a copy constructor when I send my object to the function f. Another copy, a no param constructor should come from inside the, okay, inside the function there is a no param constructor. When I return this b, it should call, because I'm going to make this assignment, it should call another copy constructor, but the compilers are smart and they say that, well, you are going to kill this object anyway. Why are you doing this? So I'm going to directly assign your b, your return b to this a. Then after that, I'm going to kill this b. Okay? So the compiler is taking a shortcut there. So what I'm saying is, definitely there will be a copy constructor during the call, it needed. But for the returned object, there may not be any copy constructors. And in fact, I believe in G++, there is an option to make such objects, okay? Always call copy constructor when you return values from classes, okay? So that's another thing. Let's continue. Okay, these are some exercises for you to do at home and try different stuff. Yeah, we did that. Oh yeah, let's do this. Let's make this just by putting in here, by putting this sign here, okay? Now I am receiving my parameter by reference, and when I compile and run this, okay, no copy constructor is called. Why? Because this is not doing any copying, right? Remember what I said at the beginning of the semester? To prevent any copying, just call it with a ampersand sign. What else? Okay, here it is. Here is something. Okay, I know that there will be a copy constructor called for this one, because okay, no param copy constructor and no param constructor comes somewhere. How about this one? Yeah. How about this one? Let's compile and run. Okay, no param constructor, and for the third one, it is copy constructor. This is not an assignment. This is initialization. And in C++, initialization is done, okay? Initialization is done by copy constructor. This one will be called, okay? Copy constructor. Let's go back and let's talk about the big tree again. Okay, what was this one is important. So again, if you don't implement your copy constructor, there will be a copy constructor implemented. For the simple class, no matter what you do, it is simple. So you don't need the copy constructor, actually. Everything works fine. But for some classes where there are pointers and that kind of stuff, copy constructors make sense. Without the copy constructor, you will run into problems. Okay, let's go to the attendance thing. I'm not going to, can I? Okay, do this. Every time I have to do this. Okay, is Ömer here? Ömer Sarıçam? Beyza? Özcan Akay? Enes Akar? Furkan Taşkın? Arif Safa? Salih Karagölü? Karagöllü? Salih?
Geçen haftaya geçtim hocam.
So he's not coming here today. So this is 11 to 7. And Yunus is the first one. Is that true? 6 seconds? Not bad. Okay, good. So let's go back out to big tree and let's implement this destructor thing. Destructor is this. If I can find my tilde sign somewhere. Do you guys know where tilde is? Tilde? Alt what?
Ems'in sol tahtası.
Yeah, I found it. I think, yeah, it is this one. Let's not. Okay, so tilde is this. This is my destructor. Destructors cannot take any parameters. They are destructors. And of course, I am not going to do anything meaningful in it. I am going to say just this. Okay. Okay, so this is going to be the destructor. Let's look at this program. Constructor, copy constructor, assignment. This one will not take any copy constructor, but inside it, there is a constructor, and this object will die, and then I have this pointer, nothing will happen with here, right? So 1, 2, 3, 4, 5 constructors, right? 1, 2, 3, 4. Oh no, this is not being constructed. Let's make this f a call by value, okay? And then I will have to kill this one. I will have to kill my object, okay, the parameter. Then I will have to kill this one. So there will be 5 constructors. 3 of them will be no parameter constructor. No, 1, 2, yeah. 3 of them will be no parameter constructor. 2 of them will be a copy constructor, and there will be 5 destructors, of course. But the order of destructors will be a little bit different. Why don't I do this way? Make it like that, so that I am calling this before I do any of that stuff. And let's run this. Compile and run. Okay. So no parameter constructor. I'm not going to get anything. Copy constructor here, right? No parameter constructor is about this one, right? And then 2 destructors. What are those 2 destructors? One of them is this one, right? The other one will be this one. Which one will be killed first, B or A? Which one will be killed first, B or A? No, B, because destruction order is usually the opposite of the construction order. Because B is my local, before B came to existence, A came. Remember, copy constructor, then no parameter constructor, okay? This one will be built first, then this one will be built, and whenever I reach this one, B will be killed, and then A will be killed, okay? So that's the destruction order. Where is my, I won't be able to see it. Why am I, okay, how am I gonna, okay, I'm going to do it this way then. Run it again, execute, compile and run. Okay, so destructor these two are from this function, okay, one of them. Then I have a copy constructor, okay, copy constructor for this one, for this one, sorry, for C. Then destructor, destructor, and destructor. Which one will be destructed first? C, B, or A? C will be destructed because it is on top of the stack, right? It to be destructed first, then B, then A. That's the order. That's known. Okay. And let's do this experiment. Cout, start, and how am I gonna find the backslash now? I can't find. Okay, I'm going to do this then. Okay. This is start, and interesting. I have a global object, okay, G. So no parameter constructor will be called for this object, but it will be called before the main, okay, starts, because our globals, they always exist before the main starts, and this is the end. Let's execute this one. Well, they said that, what did it say? I forgot my semicolon. Okay, so before start, I already have an object, no parameter constructor called before the main started. Okay, but when I come to the end, after I write end, okay, I reach this position. At this position, all of my objects will be killed one by one. So it is not right after the cout. It is okay, because cout is not my last statement in my program. My last statement is this. This means that whatever you have in your stack, local, you are going to kill them. Let me do this experiment. Okay. I am going to make this a block like this and shift it like that. Good. Okay, so I'm making it just a stupid block. So A, B, and C are local to this block. When this block ends, okay, all of them will be killed, and end will be printed after that, right? Compile and run. So, okay, so all these objects are destructed, 1, 2, 3, then end is printed. How about this destructor? Where does this come from? What is this destructor? Yeah, it is for the global. Why? Because this one will be killed after main ends. Okay, this will come from the last one. Okay, if you are confused about which one is which, where am I getting what, then do this. This is an exercise for you. Do this. Private. Okay, character C, and for example, for this one, for no parameter constructor, you will say put character, let's say A to this, or maybe no parameter N to for this one, right? So you would know, and here you will say I am going to put, although what I'm doing is wrong, put, okay, put a copy constructor thing in it here, and every time with your printout statement, print your character too. So print your character, then, and again, print your character. Okay. Do this. In your destructor too, do the same thing. C and this one. So you will understand which one is which, and maybe find a way to modify this and in your objects so that you know which one is which. Set them as, for example. Okay. If I make this not private but public, well, I shouldn't do this. I am not supposed to do that. Okay. So modify them after, for example, a.c is, for example, my first, this is a, right? Then, okay, let's do this experiment. Let's do this experiment. b.c is b. Then here, c.c is c, right? What am I gonna do now? There will be two of them. Yeah, let's do this g thing too. And here g.c is g. g.c is g. Let's run this. Let's see what kind of things I am getting. What?
Not B.
What?
B dot C.
g.c is g, yeah. Is that what you mean?
31.
Yeah, and this one is b. And yeah, is it correct now? Compile and run. Okay, so just G destructor will be called last. See, my N, what is this N destructor? B destructor, C destructor, where is my A destructor? Yeah, it is N destructor is N. What is N? No parameter destructor? Yeah, it's because no parameter. Didn't I set A.C A? Because I did this assignment. See? Assignment copied my value of B to A. So it become B. Oh, that's a different one. Yeah, that's a different one. That is inside this function. It made this, yeah, this one, because I didn't set it. No parameter for N, then I killed it. When I killed it, it is N. Okay, no parameter destructor. Okay, do this kind of experiment yourself, and it will make things clearer. We didn't implement our operator, okay? My operator assignment will take, okay, a constant object by reference, okay, and it will not do anything. I mean, it should do anything, some stuff, but I am not going to do it. I am just make this copy. I forgot my parentheses. Okay, good. And this one will be assignment. Okay, this one will be called only once. Again, this is not an assignment. This is not an assignment. Where is my, yeah, this is not an assignment, okay, operator. This is the initialization copy constructor, but this is an assignment, right? Both of them are assignments. So that assignment operator will be called 2 times, compile and run. So where is my assignment? This is the first one, and this is the first one, this is the second one. 2 assignments. Okay. How come there are so many things between them? Because I am doing the copy constructing thing, and inside F there is a local copy. It is created and it is destructed, and I am doing the assignment again. Okay, so very simple stuff. This is not much, but if you like to just try it yourself, you can type it, but I'm going to make it a little bit easy for you. I am going to paste it to our Teams page, if I can launch it. Okay, here's my Teams page. There's general. Okay. Good. Okay, let's go back to our slides. We were talking about, okay, cancel, yeah. Big three is important. Again, why it is important? When you have pointers involved, it will make sense. Destructors are part of the big tree. They will be called when your object is dying. Your object will die automatically. By the way, we didn't do this. Let's do this one more example. Okay, let me get rid of all of them here. Okay, this is our main, and let's make this a pt, guess the value of new a. Okay, so what do you expect to see when I run this? I'm going to get rid of this one too. There will be a start, there will be an end. Copy constructor will be called. I know that. No parameter constructor will be called. Okay. What else? Am I going to see another constructor for this one? An object is here, the other one is here. Am I going to see two constructors or one constructor? Why? Because this is not a object, right? This is an A pointer. This is not an object of A. How about the destructor? Am I going to see any destructors? Unfortunately, no. Why do I say unfortunately? Why do I say unfortunately? Yeah, it leaks. I mean, if I had, in this case, there is no memory leak. It's no problem. Well, yeah, you are right, actually. Because every time I make this character C will be allocated, and it is not released. Okay, it is not released. So if I do this for loop, and every time I do this, it looks like a pointer will be created and destructed, a pointer, but new a will be always there. So if I compile and run this, I compiled and I am running. Well, I wish I didn't write this one because it's going to take lots of time. Let me take this out from my, okay. Okay, because writing stuff on the screen takes lots of time. Compile and run. It started, and it is making lots of objects. And let me see if I can open my task manager. This is my task manager and my, okay. See this one is getting larger and larger. You see this one? Okay. It is almost 2 gigabytes. It is 2. So every time I make a new operator, so it's going to take just 1 byte from my memory. But I mean, it's just a memory leak, right? I'm making this new and new and new and new. So soon it's going to the operating system. Well, what happened? It's going back. Okay. Well, it started swapping. It says that you are using this kind of memory, so it's going to use some disk space maybe. Let me see. Performance. Is this my performance? Yeah. So I am using this much of memory, physical memory. When it is out of memory, it is using more disk space. Okay. And this space will get smaller and smaller. Okay. And yeah, it's going to be am I done? No, it's going to get slower and slower until I reach my theory.